Hello and welcome to the course talk for product design. I'm Russell Wade, the program leader. I'm here to tell you a bit about the course. It's broken down into three streams. As you can see, there's a BA, a BSc and an MDes, which is a master's. It doesn't actually matter which one you enroll on with us because it's your fourth year, your final year's project that decides whether you're a BA or a BSc. Even the MDes students have to be assigned a BA or a BSc in their fourth year. The MDes is an optional year you can enrol for. You can even proceed from BA or BSc to it with a 2-1 degree. To give you an idea of what we expect, the sort of person for a product design degree at Bournemouth, you need to be creative. You need to try and understand how things work, how they go together, what makes products. The curiosity element, you need to pull things apart, understand how things are built, look at the electronics, look at the structures inside components, etc. The commitment we're looking for, yes, it is an intense course of roughly 25 hours per week as a minimum, obviously with work on top. And one of the things that the course does build is confidence, because we're aiming to create fully rounded product designers that are great at the academic skills as well as the technical. Some products that our students have done over the years. The top left one, the camera going down the road, that was designed many years ago. The student wanted a perfectly remote controlled camera system that would perform a completely smooth video of his mountain biking down the hillside. Nowadays you'd use a drone, £1,000 plus. However, this is a smaller, cheaper system. Lighting systems, bike systems, etc., as you can see there. All courses are accredited by the Institute of Engineering Designers for product design. They accredit roughly 2/3 of product design courses in the UK. To give you an idea of sort of the places you'll be working in when you're at Bournemouth, we have quite an extensive innovation centre where you do your practical elements of the course. Everything from machine shops, which is the engineering machine workshop, lathes, mills, spraying, welding, 3D printers, the liquid 3D printers. We have a metal 3D printer arriving later this year, testing labs for material stress and dynamics, heat and thermofluids labs. We also have electronics labs, because lots of the products that you will create as part of the product design course will involve electronics. However, we do have technicians to help with a lot of that work. We're not expecting you to become electronics engineers as part of the course, okay? But I'll show you some of the products as we go through. So you can see it's quite an extensive innovation centre. There's a very heavy element on the practical side of the course as well as academic. More view of our workshop. That shows the testing area as well as our 3D printers. Those are the MakerBots. There are a lot more in that room, 2 industrial ones, 3 liquid Formlabs printers as well. There's not much, it cannot be made in these workshops, as you'll see when you see some of these products. One of the main aims for any student is where they're going to do a placement, where they're going to work. Our students the course has been running for roughly 30 years now, and we have students in many, many companies, from the small local industrial engineering unit right up to multinationals, Condor, as you can see, Siemens, Princess Yachts, Bentley, Dyson. We have a design show every year that lots of these companies come to just to see our students and offer recruitment. There is a placement year, as you can see. There is a fee for the placement year. It's a lot smaller than a normal year. A 15-week placement is expected to be completed. However, most students will do a year in these companies, but 15 weeks is the minimum that we would expect. We do lots of shows. There's a large one at the end of the final year, actually on campus, that students will do to showcase their work, that we invite industry into, as well as your parents, etc. And there's also new designers in London. This is a view of our new designers in stand in London. We have won many prizes, but one of the things that stands out for us at New Designers is everything you can see in those pictures is a fully functioning, working prototype that has been created by each of those students, from a hand drawing to a perfectly functioning product, whether it's got electronics, plastics, metals, woods, they're the creators of that product. Your journey, okay, so it is a 4-year degree. Your first year is sort of introducing you to the product design process. So it's not actually counted towards your degree, but you will all be doing elements of drawing, workshops, CAD, etc., learning the design process. That's been a bit crude with the view, but you'll understand when I show you some of the units in a minute how it all fits together. Year 2 builds on your first year, which is worth 30% of your degree. Then your third year, we expect an industrial placement. And then your final year, your major project. As you can see, that's the choice of direction, your BA or BSc. BAs are very humanistic, i.e. lots of interaction are involved with that product from humans, animals, etc. BScs we class as more technical, i.e. you push a button and it does something fantastic. It's a very simple way of putting it, but you'll understand when you see some of the products. The year 5, the MDes, whether you've done the BA or BSc, you can all move on to the MDes, the master's year. The main criteria is a 2-1 degree to go on to that final year. Even if you're an MDes student, you can still stop at the BA or the BSc year. As you can see, that's why I say it doesn't matter which one you enroll on, BA, BSc or MDes, you can all stop at year 4 with a BA or a BSc, or you can continue on to the MDes. Some products have been developed that have gone out into the world. The quick pitch tent, which was designed by one of our students many years ago. It was has been featured on TV programs, a pop-up tent. The Biologic Zorin pump for push bikes, and the flood stop system, which is worldwide now, developed by Simon Phelps, who now has a business based down in Poole, which is very near the university. This is how the course structure is put together. Level 4 is your first year. You can see there's 6 elements that you will need to complete. One of the main things is because we expect physical working prototypes, you need to prove that these will work. From that, you will understand that we expect you to understand the maths and physics behind your products. We're talking formula-based maths. I'm letting you understand this because it's part of the course. I will say that any of you that are scared of the maths element, there is a very high pass rate that's obviously linked to the attendance for that unit. Okay, level 5 builds on level 4, and level 6, which is worth at 70% of your degree, the biggest portion of that is your final year project, as you can see there. That thing that you will design from that hand drawing sketch to that physical working prototype, some of which you will see in the next few slides. The typical design process, I'm not going to spend too long on this. You can see it goes from hand drawings, presentation, the workshop, the making, the CAD, the electronics. It's complete concept development, testing, reiterations, presentation. A typical first year project with our students, the humane mouse trap. There is no cheese in there, so why would the mouse get in it? But that's for another day or another talk. But this is a typical first year project, very simple and something to get you into the swing of how the design process works and how you take that from a hand drawing to a presentation, creating it visually on computers, to creating it in the workshop. A second year project, this year the lecturer involved let students go out and find their own ones from real world companies. This student aimed for a shoe that would fit a trainer from the Adidas website that was designed to grow a few sizes with a foot, so these trainers wouldn't have to keep being thrown out or put into the recycling or landfill, etc. So he started with a hand drawing concept, you can see, before creating more physical designs in the workshop, before he developed this sort of strap system around the ankle, which is where he felt the area of growth was in the foot, to enable it to stretch and grow with a child's foot. And then he created a physical version. As you can see, because this involves a lot of human interaction, it's around the foot, etc., and colours and texture and feel. This was what we would class as a BA, as a final year project. This is a final year project, a baby incubator. Most of you will say they're everywhere in hospitals, but this was designed more for disaster zones and the simplicity that it doesn't need medical professionals to work. It can be airlifted into disaster zones to save children. The student created, this is the actual physical working prototype you can see here. The only thing that is not real that works is that fake baby that's in there. It was designed around the metal casing, the plastic doors, the electronic elements, but as you can see, there's only 3 buttons. That's why it was designed with the aim of anyone could open this box, push any of these 3 buttons, obviously starting with the on button, scroll through the menus and set this up to put a child in it to save their life. Okay, and it was based at 1/4 of the cost of what you would currently use in a hospital. And obviously the ones in hospitals are a lot more complicated than this. More products from our final year. I thought this was quite a good idea at the time. It's to test the pressure of tennis balls before they're issued. I mean, really, at professional matches, shouldn't this be something that is used to test the pressure of a tennis ball before it's issued to a player to make sure they're all the same, etc.? The Poppets toy, which is a very good BA project. The incubator was a BSc, i.e. human pushes the button, and most of the gubbins is behind it, the electronics, the creation, etc. The Poppets toy is based around the fact of making children active in areas they can't get outside a lot. So it involves lots of human interaction. This is where it leans towards a BA. Each of these Poppet toys has electronics inside them that's controlled by the little car with the lights on. And they're designed to be spaced around the room and pop up, make noises, and the children are meant to run around and push them down. Literally based on the colours, the cork, the grass of bringing the outside in, looking at park materials. There's a lot that goes into projects like this as a BA. Right, I have gone through that rather quickly because I'm limited by time for this presentation. If you want to find out any more about the course, you can go to the Bournemouth Uni website and look at the Product Design BA, BSc or the MDes, which I've highlighted there.